So now we are discussing 9th standard mathematics chapter 1 set language. In this last 3 to 4 days we are discussing definition of sets and representation of sets. After that types of sets. The types of set, yesterday I explained 6 types: empty set or null set, singleton set, finite set, infinite set, equivalent set. After that equal sets. Up to this yesterday we completed. Today we are going to see the remaining types of sets. So in the textbook they are given the definitions. For based on the definitions they are given the example. From that I explain the remaining types. Look at the first type. That means today's first type of a set, that is a universal set. So what is meant by universal set? A universal set is a set. A universal set is a set which contains all the elements of set of all the sets under consideration and usually denoted by U. So through a small example I will explain. Take the two sets. First, in set A containing the elements 1, 3, 5, 7, 9. Set B containing the elements 2, 4, 6, 8, 10. Universal set is very simple. What are the sets we are taking? Here 1, 3, 5, 7 and 2, 4, 6, 8, 10. We are joining all the elements. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for example, we are in one set we are taking vowels in English alphabet, that is A, E, I, O, U. In another set we are taking consonants. So we are leaving the vowels, remaining 21 letters we are taking it as a consonants. Suppose the universal set case we are joining all the alphabets in the English, that means A to Z. This is the very simple way of understanding universal set. One more time I will read the definition. A universal set is a set which contains all the elements of all the sets under the consideration and is usually denoted by capital U. What are the sets we are taking for the consideration? In the English alphabet example, in the set A I have taken English vowel, set B I have taken consonants. So in the universal set, all the letters in the English alphabet, it is termed as a universal set. So next type of a set is subset. Look at the example. Here we are going to discuss with the two types. One is they are given only one set. That time we are going to write the subset of a given set. Or second type they will give a two sets. That time we are writing the that time we are going to relate the subset of one another. Look at the first case. Look at the first case. The subset of any set contain of all possible set including its element and the null set. This definition is not given in your textbook. This I have taken from the previous year, previous edition. One more time I will write the definition. The set of any set contain subset. The subset of any set contain of all possible sets including its elements and the null set. Look at one example. Find all the subset of set A. Set A have the elements 1, 2, 3, 4. Here already I mentioned only one set they are given. That time we are going to write the subset of the given set. How sir we are going to write the subset? Very simple. Null set also subset of a given set. So first always we have to write null set. Another way of representing null set is this. This is the another way of representing null set. Any one you can use to represent the null set. After that, 1, 2, 3, 4. Each element is a subset of a given set. After that, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. Then 1, 2, 3, 2, 3, 4, 1, 3, 4, 1, 2, 4, and finally a set also a subset of a given set. What is a given set? 1, 2, 3, 4. Here also in the 1, 2, 3, 4 also a subset of a given set. So this type is a example for when a set is given. Only one set only they will give. They will ask the question, find the subset of a given set. That time you have to begin with the null set. The second case of a subset is two sets they will give. Like A and B. That time how we are going to relate the subset concept. Look at here. Let A and B be a two sets. If every element of A is also an element of B, then A is called a subset of B. We are writing this as through a symbol. A is a subset. So this is the mathematical way of representing subset. A is a subset of B. B is a subset of A. So very important condition is two set have the same elements. For example, set A have the element 1, 2. Set B also have the element 1, 2. That time we can say A is a subset of B, B is a subset of A. That's only they are given in the note point in the text. A is a subset of B is read as A is a subset of, inverted commas they are written. Thus A is a subset if A belongs to capital A. Implies A belongs to capital B. This element A is both in set A and B. Look at the example 1.7 in the textbook. Here I modify this example. They are given in the text, write all the subset of A alone. Here I am going to connect with the previous definition. What I read and the above. I am going to relate this. First we will write the subset of A. Write all the subset of A. Write the subsets, null set, element A, B, after that AB. Additionally, we are going to take B also have the same element A comma B. That time subset of B also coming the same subset, null set A, B, A comma B. Already in the definition I said A is a subset of B, B is a subset of A. That means A and B should contain the same element. Look at here, A and B both having contain the same element A comma B. So in the textbook they are given the example, write all the subset of A equals to A comma B. Here you will write this alone, subset of A or null set A, B, AB. No need to write these things. I hope you understand the subset concept. One more time I will read the definition. Let A and B be two sets. If every element of A is also an element of B, then A is called a subset of B. We write it as A is a subset of B. Now in the example 1.6, they are given a small activity. We will do it in the book itself. Insert the appropriate symbol. This is referred as a subset. This referred as a not a subset. In each fill-ups, we are going to use this two mathematical symbol. Look at the first one, 10, 20, 30 dash 10, 20, 30, 40. Asking the question, this 10, 20, 30 is a subset of this set or not? Yes, it is a subset because 10, 20, 30 containing the second set also. Look at the next case, PQR is a subset or not to the second one. Here this PQR is not a subset of the second one, because here they are given PQR, the second set they are given WXYZ, so both are mismatching. That's why this PQR is not a subset of WXYZ. The note I explained, example 1.7, write all the subset of A. This alone you have to write in the classwork. No need to write the previous explanation in the notebook. They are given the set A equals to A comma B. We are going to write the subset. So already I said this is the another way of writing null set. Any one you can write. This also null set, and this also representing the null set. Null set, set A, set B, and A comma B. So these are the way we are writing the subset when a set is given. In the textbook they are given important notes, few more important notes given for a subset. Look at the first one. If A is a subset of B and B is a subset of A, then A equal to B. Already I said A and B have the same elements. That time A is a subset of B and B is a subset of A. The second case is empty set is a subset of every set. The previous example 1.7 also explained all the empty set is a subset of every set. The third one is every set is a subset of itself. The previous example A comma B set, we written null set, set A, set B. Finally we are written the given set AB also. That's only they are given. Every set is a subset of itself. The third, today's third type is proper subset. The proper set definition, it is not given in your text. It is additional that I have taken from the previous edition. A set A is considered to be a proper subset of B if B contains at least one element that is not present in set A. There, I am going to take the two sets. First set is 12 and 24. The elements in set A is 12 and 24. The elements in set B is 12, 24, 36. The above definition itself they are given if B contains at least one element that is not present in A. In the set B 36 is there, but this 36 is not in set A. That's why A is a proper subset of B. This is the mathematical way writing proper A is a proper subset of B. Look at the definition given in the text. Let A and B be two sets if A is a subset of B and A not equal to B. In the previous cases A equals to B, like that only we have seen, but here A not equal to B, then only A is a subset of B. Keep it in your mind. Then A is called a proper subset. We are writing in mathematical way. A is a proper subset. Don't confuse. This is referred as A is a proper subset. This is referring A is a subset of B, B is a subset of A. They are given one example in the text. Set A have the elements 1, 2, 5. Set B have the elements 1, 2, 3, 4, 5. Then A is a proper subset of B. They simply written, but in the note I have written the definition, clear definition. Look at the two sets 1, 2, 5. In the set B have the elements 4 and 5. This 4 and 5 not in set A. That's why A is a proper subset of B. Next type of a set is disjoint sets. Two set A and B are said to be disjoint if they do not have common elements. In other words, if A intersection B equals to null set, then A and B are said to be disjoint set. This A union, A intersection, this set operations and all you are going to learn in the next exercise. Well in advance they are given in the text. A intersection B equals to null set. I will try to explain in the definition after this definition. through a small example. Example 1.8, they are given in the text. Verify whether the elements of set A equals to 20, 22, 23 and 24. Elements of set B equals to 25, 30, 40 and 45. They are asking the question, A and B are disjoint or not. Before that, we will understand what is meant by A union B, A intersection B. We will understand these two set operations. Easily we can write the two sets are disjoint or not. A union. So this symbol is representing union. This is representing intersection. Union is very simple. We are joining the two sets. The set A, they are given 20, 22, 23, 24. Set B, they are given 25, 30, 40, 45. Here I am going to club the two sets A and B. 20, 22, 23, 24. After that 25, 30, 40, 45. This is only A union B. A intersection B is, we are taking the common elements in set A and B. Look at here, in the set A and set B. Is there any common element? There is no common element. A intersection B equals to null set. That means whenever you are getting A intersection B equals to null set, you can write A and B are disjoint set. Very, very important concept. Whenever you are getting two sets equals to null set, we can write the given two sets are disjoint sets. The Venn diagram they are shown here in the text. This is set A. The first circle is representing set A. The second circle is representing set B. Look at here, there is no common element. Suppose these two sets are overlapping one another, means the two sets have the common elements. Here they are not touching one another. That's why this is only the diagrammatically representation for disjoint set. The last type of a set is power set. Look at the definition. The set of all subset of a set A is called power set of A. It is denoted, always we will write P of A. N of A means number of elements in the set. P of A means power set. The number of subset in a set A. That is only P of A. Look at the example. In the set A, they are given A equals to 2, 3. Then find the power set of A. Before we are going to write the power set, we have to write the subset of A. Null set 2, 3, 2, 3. These are the subset of the given set A. After that, the power set of A, we have to write inside the curl bracket. That is only very, very important. In the subset, there is no need to write the elements inside the set bracket. But the power set, we have to represent null set element 2, 3, 2, 3. We are written in the curl bracket. This is only very, very important. After that, we are going to see two formulas. Number of elements in A equals to M. After that, number of n of A equals to n. Then number of power set in A equals to 2 to the power m. Very, very important formula. N of P of A equals to 2 to the power m. The number of proper subset of a set A is n of P of A minus 1. That means 2 to the power m minus 1. The example 1.9 problem is related with the number of power set of A and proper set of A. I will explain now. Example 1.9 question. Find the number of subsets and number of proper subset of a set X. A, B, C, X, Y, Z are the elements of a set X. Now we are going to write the number of elements in set X. First write the set X, A, B, C, X, Y, Z. How many number of elements? 1, 2, 3, 4, 5, 6. So n of x equals to 6. After that, they are asking the question, find the number of subsets. After that, find the number of proper subset. The number of subset formula already I noted, 2 to the power m. This m is referring what are the elements in the given set. Look at here, n of p of x equals to 2 to the power 6. The number of subset equals to n of p of x equals to 2 to the power m. In the place of m we have the number 6. So we have to express 2 6 times. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. So number of subset in set x equals to 64. This is only meaning for this. Number of subset in x. So always keep it in your mind. The number of subset in a given set formula is 2 to the power m. M is nothing but how many number of elements are in the given set. After that, number of proper subset. The formula is 2 to the power n of p of x minus 1. We are writing this as a 2 to the power m minus 1. 2 to the power m minus 1. What is 2 to the power m? We got already 64. So n of p of x minus 1 equals to 2 to the power m minus 1. Any one of this you can write. Always you have to write this. Very simple. You can keep it in your mind also. Without any confusion you can keep it in your mind. So 64 minus 1 gives 63. The number of subset formula is 2 to the power m. The number of proper subset formula is 2 to the power m minus 1. Students, I hope you understand this number of subset and the number of proper subset of a given set. We completed all the types of sets, and I explained through examples. Few more examples I have taken from the previous year text, and this all the examples and the definition help you to understand the types of set in a clear manner. Before I conclude today's class, I am going to explain the types of the sets alone. Totally we have 11 types of sets. The first one is empty set or null set. We can represent the null set in two ways. This also representing null set or this void. After that, singleton, finite set and infinite set, equivalent set, equal set, universal set, subset. After that, proper subset, disjoint set, and finally power set. And finally I have given two important formulas. Number of subset equals to 2 to the power m. Number of proper subset equals to 2 to the power m minus 1. Students, based on the today's types of set, we are going to discuss the exercise 1.2 remaining problems tomorrow. I hope you all understand the types of set. This PDF will send in the respective class WhatsApp group. From that you can copy the definition and the examples in a clear way in your classwork note. Every day you are attending the test. I hope you are all getting full mark, 5 out of 5 in previous tests. It's very simple. What are the sums, what are the definitions, examples we are using, that questions only we are going to ask in the test. Few more sums, a few more things only, numbers only we are changing. So carefully you have to listen and watch the videos. You will get the mark. All these things are helping you to to get a good mark, not only in the 9th standard, this proper set, subset, then power set, these things and all in college level also. So very important concept in the types of set, this subset, proper subset, and power set formula, the number of proper subset formulas. So these things and all carefully you have to recall then and there. Then it will help you to learn your lessons in the upcoming academic year also. Tomorrow we are going to discuss the remaining Roman numbers in exercise 1.2. The remaining Roman numbers are 3 to 10. So all the sums are related with the types of sets only. After completed your classwork, go through the types of set one more time. I'll join with you exercise 1.2 problems tomorrow. Thank you.